Hello everyone, welcome to Learn with Dr. Shobha Nikam. In this video, we will see how to write code for D flip-flop using VHDL. So VHDL stands for Very High Speed Integrated Circuits Hardware Description Language. So this language is basically used to describe hardware, and today we will describe the simplest memory element, D flip-flop. So here D flip-flop is nothing but a memory element which can store one bit of information at a time. So here input is data input D. Then every flip-flop has one input clock input. And here I have shown rising age triggered clock. And then reset input, see, in case of D flip-flop, whichever value we will apply at data input will come to output at rising edges of clock. But in between, if I wanted to clear the contents at the output, if I wanted to make output 0, then I'll use reset button. So job of this reset button is, if I'll apply 1 at reset input, it will simply make output 0. That's it. And Q bar is complement of Q. So here inputs are data input, clock input, reset input, and outputs are Q and Q bar. Now see, reset can be asynchronous reset or synchronous reset. So in this video, I'll tell you how to write code for synchronous reset as well as for asynchronous reset. But in exam, if question is to write a VHDL code for D flip-flop, you can write any one code. No need to write both codes. But if it is specified to write VHDL code for asynchronous reset or synchronous reset, in that case, you will have to write that particular code. So asynchronous reset, see, there are two terms, asynchronous reset. Don't get confused with synchronous circuits and asynchronous circuits. Synchronous and asynchronous circuits, these terms are applicable when we have multiple flip-flops. And asynchronous means single clock is not connected to all flip-flops, whereas synchronous means single external clock is connected to all flip-flop. That is about circuits. Here I am talking about asynchronous reset input and synchronous reset input. So see, synchronous reset, it means reset will affect the output Q only if clock will come. It means if rising edge of clock will come, and then if reset is 1 at that time, when clock is 1, at that time if reset is equals to 1, then output will become 0. That is synchronous reset. Synchronous means it will wait for clock or it is dependent on clock. Asynchronous reset means reset input is asynchronous. It will not check whether clock is coming or not coming. As soon as reset becomes 1, output will become 0. So if there is clock input present or absent, reset is 1, output is 0. So today I'll tell you how to write code for both asynchronous resets and synchronous reset. We'll start with asynchronous reset. VHDL code is divided into 3 parts. First is library and package. Then comes entity, where we define how many inputs are there, how many outputs are there. Then comes architecture, where we define how my circuit behaves or functionality of the circuit. So if you know C language, like we include header files, here we include library and package. And there we define our inputs as integer, float, character. Similarly, here we define how many inputs are there, which inputs are there, which outputs are there in entity. And in C language, the way we write void, main, and then code in curly brackets, here what we use is architecture. See, I have prepared separate videos about basics of VHDL, what is library, what is package, how to write entity, how to write architecture. While writing architecture, again, there are 3 types, modeling styles. So links for all these videos are given in the description box. So here I'll not explain all these things again, otherwise length of this video will become large. So let's start with D flip-flop using VHDL. So very first is we must include library files. So here library is library IEEE. This language is case insensitive. So you can write capital IEEE or small IEEE. Both will act same. So library IEEE use This is package. Use IEEE dot standard underscore logic underscore 1164 dot all. So after including these library in any VHDL code, these two lines are mandatory. You must include library and package. Next is entity. Syntax for entity is entity. First word is entity. Entity name. So here I am writing code for D flip-flop. So I will write D underscore FF is. Entity D flip-flop is port. So here we are writing code for our hardware. So we need to know port. Then bracket. How many inputs are there? D, clock and reset. So what I'll write? D, comma clock, comma reset. All of them are inputs and all of them are single bit inputs. So D, comma clock, comma reset. Their direction colon and their direction is in and their data type is standard underscore logic. I have uploaded video related to data types. The link is given in the description box. In standard logic. Now next is how many outputs we have? Q and Q bar. So I will write Q, comma I cannot use Q bar as it is. So I'll write Q bar in this way. And the direction is out. So out. Data type is standard underscore logic. We are done with all inputs and outputs. So I'll close this bracket here and then semicolon end our entity name D underscore FF semicolon. So this is library. This is our entity. For asynchronous reset as well as for synchronous reset, entity will remain same because in entity we are not explaining how my circuit behaves. What I am doing is I am only telling you how many inputs are there and how many outputs are there. That's it. So now let's write an architecture for asynchronous reset. So syntax is first word is architecture. Architecture. Here architecture name. So generally we use modeling styles name as an architecture name. So to describe sequential circuits where clock is present, where memory elements are present, we use behavioral modeling style. So architecture behavioral of, for which entity I am writing this architecture? DFF of D underscore FF is architecture begin. Here we don't use any curly bracket and all. We use word begin. Architecture begin. Then in behavioral modeling style we use process statement. Process. And here this bracket is called as sensitivity list. So in sensitivity list we include inputs to which our process is sensitive. It means if these inputs will change, my output should change. So now see, if D input will change and if clock and reset will not come, our output will not change. Even if my data input will change thousands of times, my output will not change. So my process is not sensitive to data input. So what I'll write? Clock is important and reset is also important. You can include all inputs also, but the best practice is to write inputs to which process is sensitive. So clock, comma reset. Then I need to start process. So I'll write begin. Then now I'm writing code for asynchronous reset. It means reset is independent. So if reset is equals to 1, it means if I'll press reset switch, if reset is equals to 1, then what will happen? What will happen, you tell me? If reset is equals to 1, my output will become 0. So Q is assigned as, this is an assignment operator. I'll put link for these operators in description box. So Q is assigned as 0, semicolon. Then if clock will come, so see, if as soon as I'll press reset, then my Q will become 0. And what about Q bar? Q bar is not of Q, complement of Q, not of Q. Now, if as soon as reset will become, output will become 0. That's it. Remaining code. If clock will come, then what will happen? So, after this, here you need to continue. Else if means if reset is not pressed, now reset is 0. Then else if, now here I'll not write complete ELS, E, IF, because then new if statement will start. So else if, this is inbuilt function, rising underscore age of clock. Then it means else if rising age of clock will come, then what will happen? See, if my flip-flop is falling age triggered, then instead of rising age, I'll write falling underscore age. So else if rising age of clock will come, then, so at every rising age of clock, this is my clock. So at every rising age of clock, it will check what is value of data, and based on data value of data, what I'll get is Q. So at rising age, Q is assigned as what? D. And in between two rising ages, what will happen? Q will remain same as previous value of Q. So else Q is assigned as previous value of Q. It means when rising age of clock will come, then this new value of Q, D, will go to Q. But if rising age will not come, then it will hold previous value. So else Q is assigned as Q, and Q bar is assigned as not of Q. Here, if started, so end if. Before if, process was started, so end process. And before that, architecture was started, and you need to end every line with semicolon, end behavioral. So this is code of D flip-flop for asynchronous reset. So here you can see in simple way, you can remember reset is outside this loop for clock. Reset is independent of clock. Now let's see how to write code for synchronous reset. See, library and entity will remain same, only architecture will change. So architecture behavioral of D flip-flop is begin, next is process and sensitivity least. Now previously clock and reset was written because process was sensitive to both the input. As soon as reset becomes 1, output becomes 0. But in case of synchronous reset, even if reset will become 1, until and unless rising age of clock will not come, output will not change. So see, even if reset will become 1, my output will not become 0 because it will wait for clock. So process is sensitive to clock, not to reset. So here the change is process is sensitive to clock. Process begin. Now, if rising age of clock will come, rising underscore age of clock input will come, then now if clock will come, then it will check whether reset is 1 or 0. So first it will check reset is 1 or 0, and then it will check what is value of data input. So in that, if reset is equals to 1, then so rising age will come, then it will check value of reset. If reset is 1, then automatically this Q will become 0 and Q bar will become not of Q. So if reset is 1, then Q is 0. But if reset button is not pressed, then for this if I'll write else, then Q is assigned as D. So at rising age, whichever value is present at data input will come to output Q, semicolon. And Q bar output is, of course, not of Q, that's it. Now, I'll end this if, end if. So, if reset is 1, output is 0. If reset is equals to 0, output will follow data input, that's it. Then for if rising age will not come, what will happen between two rising ages? So if this is my clock, in between these two rising ages, here whichever value of data is present. So if data is 1, let's say data is 1 and this is my clock. If my data here at rising age, data is 1, so my output, let's say initially output was 0. So here my output will become 1. But here, even if my data becomes 0, my output will not change because it will wait for next age. So up to next age, it will hold this 1. And here it will check data is 0, so output will become 0. So see, here for this duration, data input is 0, but my output is holding previous value. So in between two clock ages, it will hold previous value of Q. So if rising age will come, then these things will happen. But if rising age will not come, then Q is assigned as Q. It means next value of Q is same as previous value of Q. And Q bar is, you simply need to write not of Q. That's it. And so here I need to write else. For this, if I'm writing this else. If rising age will not come, then this will happen. And then I'll write end if. This end if is for this if. Then end process. And then end behavioral, our architecture's name. So this code is for synchronous reset. So see, synchronous reset means reset is written inside this clock. And asynchronous reset is where reset is written outside the clock. It means reset is independent of clock. Here reset depends on clock. So this is all about code for D flip-flop using VHDL for asynchronous reset as well as synchronous reset. In exam, out of these two codes, you can write any one code. See, also entity and library will remain same. So here before this architecture, you need to write entity and library files. In few codes, you may find there is no Q bar output. But in our D flip-flop, we all know there are two outputs. So you must mention what is value of Q bar, and it is not of Q. So thank you so much for watching this video. If you find this video useful, share it with your friends. And don't forget to like and subscribe to my channel. Thank you. Thank you so much for watching.